Continuing with factoring trinomials where the lead coefficient is larger than 1, we're going to look at another method today. I don't necessarily, you can do this method with any of the problems you face. Some of the numbers that you work with will be rather large, and so it may be easier to do the method that we did yesterday. Like number 2, we're going to do, plus you have your lead coefficient is prime, so we're just going to set it up as we did yesterday, which is a great review just to get us going. So, first thing we do, we're going to do the 2K. Are our signs going to be the same? No, but we don't know where they're going to be yet. So, factors of 45. 1 and 45. 2 doesn't go. 3 and 4 doesn't go. 5 and, as you said, 9. 6 doesn't go. 7 doesn't go. 8 doesn't go. And we're back to 9. So there we are. So we need to subtract the outer and inner to get a positive 1. So let you work it. Tell me when you get it. 45 is going to be a big one. I wouldn't even attempt it because you're trying to get two numbers that are side by side, so when you subtract, you get 1. I'm hearing it quietly stated. Jack, are you seeing how to put it together? You know, and it never hurts to, like put the numbers here or here. Well, then your signs are wrong. You want a positive one.
Wait, they're not. I got it right. I got it right first. But then it'd be plus 5 if it was a different sign instead of -1.
Not true.
Yeah.
No. All right. So what did y'all get?
15 and 3.
5 and 9.
I know.
15 and 3.
Okay, if we did 15 and 3, that's going to be 30 minus 3.
How?
Well, if you did this.
Because 15 times 3 is 45. And 2 minus 3 is negative.
No, that's not how you do it. All right, so you said, which way did you go? You put the 3 here?
Yeah.
And the 15 here. What is 15 minus 6?
No.
Right, not 1.
Where do you get 6 from? Yeah.
Well, 2 times 3, your outer is 6. Your inner is 15. Subtract them.
I didn't. That's not how I did it.
Well, all right. So we have agreed that it's not 15 and 3. 5 and 9.
But what are the signs?
All right, hold on. Let me rewrite. So we're going to have 2K, and we're going to have a K, and we're going with 5 and 9. It's either going to be here. They both fit because neither of them are even. So you could have 2 times 9 is 18. 18 minus 5 gives us 13. So it's not that one. Hold on.
I was thinking 9 and 5.
So then we look at the other. What is 2 times 5? 10. What is 9 times 1? 9. What's 10 minus 9? 1. Hark. All right, Avery. How do we do the signs?
The biggest one's the positive.
But she's got to say which one. I want her to see if she can tell me. You're right. So here are Avery, Eli, kind of sounds alike, I'm sure, somewhere. Which of these, the 10 or the 9, do you want to be positive?
You want the 10 to be positive.
And which set, 2 times 5, come on, pen, there, or 9 times 1 gives us 10.
2 times 5.
So this has to be positive. So plus, minus. Sorta.
Yeah.
Okay. All right. I'm going to show you now the other method that we talked about. Any other questions on this before we move to the other method?
Wait. Pause.
She didn't say anything.
You sure?
I think so.
Okie doke. All right. This other method has a name to it.
Is it easier?
In a lot of ways, yes. All right, so let me change. It is called bottoms up. Bottoms up. All right. When you could do it with the first one that we just did. You'll just probably need a calculator to list all the factors, because here is how it goes. You're going to take the first, let me move it up, number, your lead coefficient. In this case, it's 3. And you're going to run down here and multiply it by the last number, -4,
12.
which gives us what?
12.
12, well, or -12. So we're kind of like going into an alternate
What, so do we need-
state of life when we
need
do
the
this.
V2 there?
Yes, we'd only take the number. So we're going to live over here in this alternate state for about 3 minutes, and then we'll have to come back to reality, all right? We move it, and we're left with v squared minus 11v minus 12. What's our lead coefficient now
V2.
for this moment?
V2.
What number is it?
1.
1. So do y'all remember before Christmas when... No, you probably don't remember before Christmas. Never mind, unless your name is not. Yes. The rest of you, do y'all remember what it was like before Christmas when we had a lead coefficient? Yes, you do, of just 1, because you did it on the exam. You didn't have to worry about the first factors. You didn't have to worry about where you put your signs, because it would work. You just did the V and the V. We know we need opposite signs to get to -12. So we're going to have a plus and a minus, which means we're going to subtract to get what? 11. So let's list our factors of 12. We're going to have 1 times 12. And we're going to have 2 times. And we're going to have 3 times.
4.
And then we're back to 4 times 3. So we leave it. All right. When we work with this, we then need to subtract to get 11. So what's 12 minus 1? 11. But then go ahead and look. 6 minus 2 gives us 4, and this gives us 1. We still only have one way to work it, and that is 12 and 1.
We've always subtracted.
We need it to be a negative. So which number takes the negative, the 1 or the 12?
The 1.
12.
I'm going to beat my head on the wall. We need the larger number to be negative. It's coming. It's coming. Even boy who doesn't remember this he remembered that part. So far, so good.
So you can do this on any problem?
Yep, but we're not through. Now, in real world, in the real reality, what is our lead coefficient? Go look at the first problem. What's the 3? We now need to create our altered state and get us back to reality. Here's where bottoms up comes in. We had initially taken the lead coefficient and threw it in with the last number by multiplying. Now we need to take it out of the last numbers by, what's the opposite of multiplication? Division. So I'm going to go divide. Don't do the V's, don't do your variables. You do the last numbers in your binomial, okay? So what is 12? Can you simplify either of those fractions? Yes.
The last one.
The last one. And what is it? 4. So the last is going to be V minus 4. Now, when you're looking at the other fraction, if this had been like 2/6, you would need to simplify it to 1/3 to go ahead and simplify it all the way out. But we can't make it a whole number. Here's where bottoms up comes in. You take the 3, the bottom, and throw it up as the lead coefficient in the binomial. And we have 3v plus 1.
So is that it?
And we're back. Mm-hmm.
So is that like a different way to do it?
Or can we still
No,
use
that's the
that? Can we
same
still
one,
use that?
yes.
I'm using this one.
Thank you, Gabe. You're welcome.
Wow, okay. Well,
That's why we even gave it a name of bottoms up.
Using the old one.
Yeah, we talked about any method that, yep.
Yeah, I didn't notice you did like that, and I kind of thought it was the same. Because we started out the same.
No, we took the lead coefficient and moved it. Then it became the same. All right, so that will work for you on every problem. Sometimes you end up, if we had done this on the first problem and we had 2 times 45, that's going to give us 90, which you would have to list out some numbers, but you could have gotten there. You know, it's just bigger numbers. All right, 6. What's the first thing you've got to check for every time? Common factors. What are they? 5 and n. Hint, your lead coefficient should always be an n squared in this trinomial. So if it's not, double check your variables. So we're left with
N squared
5n squared
plus 11 and
plus 11n
plus 2.
plus 2.
Oh my God.
With removing the factors. Yeah. Now, you can either do it, either method will get you the answer. Okay? But do you want to do bottoms up one more time to see how this works?
No.
Well, then you just sit over there, put your fingers in your ear, and don't listen. All right. Take the lead coefficient. Your greatest common factor just travels along. All right? 5n. You don't do anything with it. So we're going to just stick it out here so we don't lose it. And we're going to multiply the 5, or this is an easy one, times 2. So n squared plus that 11n doesn't get affected at all, plus 10. Oh my goodness. 2 factors that multiply to give us 10. I bet you don't even have to list them, that give us 11.
10 and 1.
10 and 1. 2 and 5 only give you 7. All right. So we're going to say, and you don't have to worry. I love it when it's the same signs. You don't have to worry about it. So 10 plus 1. N plus 1, n plus 10. And I'm going to still bring the 5n down. All right. Good to that point.
Dr. Brown,
Sir,
did we go some flip-flop it?
could we put the 10 first and the 1 last? Is that what you're saying?
Yes, ma'am.
Yeah, sure. It won't matter because it's the binomials mean multiplication, so they can be in either order. All right, what's the next step?
Go get
Get the N word.
5.
That 5, which is not your greatest common factor,
Oh, yeah.
but the lead coefficient. Get this 5 and put it where, Lillian?
Under the 1 and the 2.
Under the 1 and under the 10. Perfect. So what is our final answer?
5n plus 1.
5N.
5
N plus 2.
And then N plus 2.
N plus 1.
I thought you weren't listening.
So it's N plus
No,
one.
I guess not. Yeah, I just don't like it. So we can move it the other way now. So now-
We just did.
Oh, yeah.
You would. Your 5 is prime, so you only have 5n and n. And then for 10, you would have 1 and 10, 2 and 5. The 10 cannot go in with the 5, nor can the 5. So you only have 2 options, either 1 and 10 or 2 and 5. Because remember, we can't put common factors together. And so 5 times 10 is 50, way too big. So 5 times 5 is, wait, I lost myself. Oh, no. Yeah. I was up there.
Wait, so if I do it the other way, 5n, and then n plus 1, n plus 10 would be the right answer.
Mm-hmm. Whoops.
So then why would we even do the other way? This is longer.
This one is pretty straightforward. This particular problem. It just, like I think number 10. I mean, you can do it. Some people, the lead coefficient, when you have options for it, sometimes the lead coefficient can be more, when you've got like 2 or 3 numbers that could be the factor, that alleviates a little more of the work. And I have seen where some people totally blow off the lead coefficient and they get it wrong every time. But if you can make the lead coefficient 1, it helps you back into the right answer. Trilby.
Wait, so wouldn't you like simplify 10 over 5 to where it'd be 5 over 1?
Hold on. I probably just did something. Let me maybe back up. I may have written it wrong.
Laird Johnson, can you come to the senior high front office? Laird Johnson.
Wait, where?
On like 10 over 5 at the end. Would you simplify that?
We did to 2.
Okay.
Would you just multiply the 5 by
Wait, would you do what?
would you multiply the 5 by the 2? Say how you got the 10?
It's not legal.
Yes.
You just took away the 5 and the n squared.
So what, for bottoms up? Yes, we took the lead coefficient. I hate in this problem that they're the same as the GCF. We're not doing anything ever with the GCF, it just travels, okay?
Gotcha.
So take the lead coefficient, multiply it by the last number. That's 10. So now the lead coefficient, like in our altered state, is 1.
Gotcha.
So you don't have to think about, it's just gonna be n and n.
Gotcha.
And then then you've got to figure out 2 factors that equal 10, that when you add, in this case, you get 11. So it's going to be, 10 and 1. Write those down. But then you've got to we've got to get the lead coefficient pulled out. So divide. And then simplify. 10 over 5 is 2. Can't simplify 1/5, so bottoms up. The 5 comes out as now the lead coefficient, leaving the 1.
So you divide by the lead coefficient.
Alrighty. So number 10, is there a greatest common factor?
Yeah.
Yeah. What is it?
2.
No. Yes. So lead coefficient of 4, which leaves us with,
5n squared.
yes, minus
5n squared.
5 minus 4 is 1. Bring down the 2 is 12. So 12 divided by 4 is 3. So 13n minus,
So 31.
so it's going to go in, 4 goes into 11 2 times. And that gives us 32, which gives us 8, 28. So,
How do you work from there?
do what?
How do you work from there?
Either method.
The first
Lead coefficient or multiply the 5 times the 28.
So you multiply.
You can either do bottoms up or the regular method.
How can you do the regular method?
Uh-huh. Yeah, this one is 100, but it's 140, which that's not a bad listing of factors. So if you want to do it just regular way, the 5 is prime. We don't know the setup of our signs yet, but we know we have to subtract. So 28. 1 times 28, 2 times
14.
3 doesn't go. 4 times 7, 5 and 6, and then 7. So then you need to do the outer and inner to subtract to get 13.
5 times. Wait, is it 7 and 4? I think it might be 7 and 4. Wait. Yeah, it is.
Mm-hmm.
It is 7 and 4.
It is.
You knew it.
Yay. All right, just quick question. As you're going, I would be if you're doing bottoms up, as you're listing the factors of 140, I would subtract as well each time. 5 times 28. Well, we did, if you're doing bottoms up. I saw some people grabbing the calculator and I knew they were doing bottoms up.
Can I come here and study home?
When is that? Fixed gear.
Do they get it?
Mhm.
I don't understand this stuff.
Well, you know how we got 140? Take the lead, the 5, and multiply it by the last.
That's why you just stick to the regular ones.
The bottom's up. You got 5 times 28 is 140.
It's 140.
So I'm listing the factors of 140, but I'm subtracting them each time to get to 13. Because I need 13. If they don't work, then I'll throw them out.
Okay.
So like 140 minus 1, 139. That don't work. And 70 minus 2 doesn't work. 35 minus 4, we're still not to 13. We're getting closer. What's 20 minus 7?
13.
20. No,
13.
20 minus 13.
Found it. 20 minus 7.
Boom.
So I'm going to put,
Boom.
if we're doing bottoms up, then I'm going to have N and an N, and I can put a 20, and I can put a 7. And then from there, we're going to put the 5 back underneath. So that means we have an N and a 4,
5 in.
and we have a 5 N and a 7.
So plus or minus 7.
All right, then we have to go, we need a negative 13. So here we are. We have 7 and we have 20. We need the 20 to be negative.
Okay.
5N plus 7, N minus 4.
Is it fun if you like flip it?
For me, this is just personal. That answer bugs the stew out of me. I want it to be 5N plus 7 parenthesis N minus 4. I like my larger stuff first. And it's just me. It doesn't make it wrong. So check out, I want you to try bottoms up with 22.
Wait. 3, 6.
120. Oh wait, 22.
So
Which also has to add up.
Do I?
x squared minus 2xy.
Do you just do the normal 16 or do you do the last square?
No. No, we only work with numbers. Minus 80y squared. And you're just looking for factors of 80 that when you subtract, you get 2.
Minus 4.
Did we ever find factors of 80 that equal 2? Yeah, 10 and 8. And it needs to be minus 8 and plus 2. I mean, oops, sorry, my bad. Minus 10 and plus 8. Because we need it to be a negative 2.
Did you not put the Y's behind the eight?
Oh, thank you. Put the Y's. Yes, be sure you have your Y's in. Go back to the lead coefficient, which is 5. Can you simplify either of those?
The second.
The second, 10 divided by 5 is? So the last one's going to be x minus 2y. What will the first one be? 5x plus 8y. Alrighty?
So if you can't simplify and you move it to the right,
It bottoms up. But be sure, if it had been like 16 over 10, you need to be sure it's simplified all the way. Or when you move it, it will be sharing factors. And it can't. So be sure you have the simplified fraction before moving it. All right? So, let me just say this. On a test or quiz, I am not going to have a section that says, you must use bottoms up. This is just giving you another little tool in your toolbox in the event you're looking at a problem and you're going, I don't even know what to do. Or you've got maybe a lead coefficient of 12 and it won't simplify. There are no greatest common factors. Well, 12 has several options for factors. So you'd be doing a lot to work that problem to figure out what your options would be. So if you change it, make a lead coefficient 1 so that you're not as bothered with it. Now, let me tell you what your homework is. Let me turn off the recording.